Now, how do you store those values of the pixels in a file? So what you do is you store red, green, and blue values in little triplets, effectively, with different values that each make up a single pixel. So the values range from 0 to 255. 0 would be very dark, 255 would be very bright. And triplets of these values together compose a single pixel.
An image file, whether it's a JPEG, GIF, PNG, etc., contains millions of these RGB triplets. So how does the computer store all that data? All computing and digital data are represented by bits. A bit has two states. It's on or it's off. But instead of on or off, computers use ones and zeros. Binary. So an image file is actually just a bunch of ones and zeros. But why do RGB values go from 0 to 255? Turns out that each color channel, RGB, is represented by 8 bits, which together are called a byte. If you know the binary number system, you know that the maximum number 8 bits can represent is 255, which is equal to 8 ones in a row. And the lowest is 0, or 8 zeros in a row. Therefore, 0 to 255 gives us 256 different intensities per color channel. We could represent a pixel of the color turquoise, for example, in our traditional decimal-based number system as 64 for a little red, 224 for a lot of green, and 208 for some blue. But a computer would have stored it as 01 00 0000 111 00000 1101 0000. We use 24 binary digits to represent this one pixel. So rather than binary, digital artists often use the hexadecimal number system to represent colors. So we can represent the same color turquoise using only 6 hexadecimal digits, so 40, E0, D0, which is a lot shorter.
Let's say you want to modify the colors of the image. How do you do that? Basically, there are ways of mapping functions where you take the input value of the pixel, so you take an input of a red, green, and a blue value, which represents that color, remember, and then you map it using a function to a new red, green, and blue value. Let's say you wanted to make an image darker, right? One way of doing that is by taking the red, green, and blue values that come in, and let's just say subtracting a fixed constant from each of them. So subtract 50, right? And obviously you can't go below 0, but you just subtract 50 from each of them. And that's the output. So the input is RGB, and the output is R minus 50, G minus 50, and B minus 50. What you'll see is you take in an image with a certain brightness, and you get out an image with a much darker brightness. What a lot of people don't realize about Instagram is that initially people thought what it was a way of filtering your images, making your images look cool in some way or retro. And what it grew into was actually much more important. It was a way of people connecting. So it's not just about seeing photos of your friends and your family, but actually being able to discover things happening all around the world. Whether that's a riot overseas, a social movement, you're able to basically consume that information in a visual way. And that allowed us to grow very quickly and be a universal platform.